Welcome to the Alphalist podcast. I am your host, Toby. Alphalist is a closed community with over 400 CTOs who share their knowledge and experience in a Slack space and at events. With this podcast, we want to give our members and interested parties insights into the thoughts and ideas of top CTOs. If you're interested in becoming a member of the community, please visit alphalist.com to find out more on how to apply. This podcast episode is kindly presented by MongoDB, the successor of the NoSQL movement. It's a very attractive, flexible, and simple database system that can be integrated in no time. They have a developer-first approach and build a system that is fun to use and scale to terabytes or petabytes. You don't have to think too much about your database structure. Just start playing with it and develop it on the go. I tried their new cloud product called MongoDB Atlas, and all listeners of this podcast can easily do the same and test it in their favorite cloud: GCP, AWS, or Azure. Custom-tailored deployment without over-provisioning, sandbox for developers, organized in microservices, and clear focus on developer fun and quality. To keep it simple, DevOps with more dev and less ops. Just go to cloud.mongodb.com and use the promo code podcast2020 to get started using their database as a service in the cloud. So, today with me is my friend Tyler McMullen, CTO of Fastly. Tyler, maybe you could introduce yourself.
Hi, I'm Tyler McMullen. Again, I'm the CTO of Fastly.
It's an honor to have you here. I think, whenever talking to other geeks, I'd like to learn more how they got into computing their geek path. So maybe you could do me the favor and tell a bit more about your childhood.
Oh, good. Let's start with my childhood. So I had maybe this isn't actually as weird as I think it is, but I'm not sure. Did you have Game Genies over here for the original Nintendo system? NES?
Yeah, I think so.
Yeah. So I had an NES when I was like 5 or 6 years old, and we got a Game Genie to go along with it. And I had been trying to figure out how the codes worked. And eventually, someone explained to me that it was actually just modifying memory locations within the program. And suddenly, to me, that was the first moment where I realized that video games weren't magic, and that it was something that it was just a machine that one could manipulate and create and so on. And so that's really the thing that got me interested in computing back then.
Okay. So you started with gaming, as a lot of geeks these days do, yeah?
Yeah, like QBasic.
But you then straight away got into programming, or?
Well, it was a couple years later before I actually got into programming, and it started with QBasic because it was the thing that was on the computer that my parents had, and I could also find books on it at my local library, and got from there into C, and then from there I got my first job, actually doing very early web applications back in 2001 or so.
In which language? Perl or?
Oh, it was in, it was actually in classic ASP. I was a Microsoft guy back then.
ASP, wow,
yeah.
Impressive. I actually also started with ASP, or used to do ASP years ago in combination with Flash. Yeah.
Okay.
So, very bad time.
It's a rough time.
Don't like to remember it, yeah. And then you started, or you continue with different other languages, or how did it evolve?
Yeah, from there, I actually got laid off of my first job. It was kind of it took a long time for the .com bus to hit Pennsylvania on the other side of the continent from California. But when it did, I got laid off, and so I started doing contract work. And ended up using a bunch of Perl and PHP, and eventually that led me to the Ruby world, and I did Ruby on Rails for quite a number of years.
Yeah, so we have quite a bit in common, yeah.
Good.
I was never laid off, but I also did Ruby. But it's also not that common in Germany to get laid off, as we have a very protective work environment here.
Sounds nice.
Okay, and when did you then, or how did it continue? You studied IT, and then how did you guys meet? I mean, how did you come to Fastly, where you are now.
Oh, sure.
I mean, you're a co-founder, right?
Sure. I actually didn't study IT. I went straight, like I got my first programming job when I was in high school at like 16 and just never actually bothered to go to school after that. And so, which is how I can be 35 with almost 20 years of experience. But no, so I ended up in California at one point working for another startup, and I was actually sleeping on a friend's couch when I met the person who's like the primary founder of Fastly, Artur Bergman, and we got to talking about it. And he was telling me that he wanted to make something that was like a CDN, but was really more of an edge computing network. And that was exciting enough to me that I went and quit my job and joined him.
Okay, and he's also, as we say, techie, or?
Oh, very much so.
Yeah. So you're a very tech-driven company then.
I think that's true. Like, that obviously has like evolved quite a bit since we first started. But like the first several people who were part of the company were all like pretty serious programmers.
Okay.
Yeah.
Okay. And that's pretty much also your elevator pitch, I guess, or?
No, I mean, I guess the elevator pitch is a little bit different nowadays anyway. It's really more like, Fastly is about not just moving your content, but moving your logic and your actual applications out to the edge of the network. So Fastly is not just a CDN, but rather an edge cloud.
Okay, and that's what you currently do as well, or is it somewhere in the future?
No, I would say that is what we currently do. That's what we've been, slowly evolving towards since we started the company.
And how can I imagine an edge cloud? I mean, you have data centers everywhere, I guess, or computers and data centers everywhere. Is it like big ones or like rather smaller ones?
Well, it really depends on where in the world we're talking about. Our POPs, our points of presence, are anywhere from like 8 to, I think at this point, 128 servers in each location. They're like big beefy servers, right? So they can do quite a bit, like terabits of traffic for some of them, in theory anyway.
Okay, and where's the next one? Where's the next one from? We're sitting in Berlin. Where's the next data center here? Do you know that?
I'm pretty sure I can't say that.
You can't say that. Okay.
I cannot say, unfortunately.
Okay, then that does mean that you're actually doing something like Amazon Lambda, then running in a CDN, running in a varnish, as far as I know, like a forked varnish.
Yeah. So the way that I think about it is that. With traditional clouds, all the clouds that are out there, they tend to be focused around like a centralized deployment model, where typically you will deploy your application to one place and you might choose to deploy it to another place as well. Fastly has a much more, what I would describe as like a serverless, almost like a data centerless sort of model to it. Mm-hmm. Where you don't need to necessarily care where your code is running. Basically, you provide the code, you provide the application that you want us to run. We provide the primitives that it can be programmed against, and then we'll deploy it everywhere. Okay, interesting. So somehow comparable to Lambda, but just that it's not centralized. I mean, with Lambda, I guess you know where your code is running in a particular data center, which you pick, and at Fastly, or maybe also other CDNs. I don't know. It's working that way that you deploy it everywhere. That's the idea. Yeah. I'd say it's like, I would say that like the whole concept of the edge cloud definitely isn't like intended to replace the central cloud. Like they actually work in tandem. They work together really well. Right? Like we actually work together with GCP and AWS and so on pretty frequently.
Okay.
Like
so the idea is basically not to put like compute heavy things in your CDN, but rather smaller tasks that need approval or something like that for deployment, for delivery. Or
again, I think the way I think about this one is it's more like you would want to put the things at our edge that are valuable for them to be fast, right? So they are things that either latency is extremely valuable for them, or resiliency is extremely valuable for them.
Okay.
So like in a lot of cases, people or companies that use us can have their entire like central cloud go down or go away, and their website or their application will continue to function normally, just like degraded slightly, right?
Okay.
So that's the idea.
Okay. So basically like having a local varnish, but like really spinning that to the cloud. and not maintaining it yourself. I think that's also like a very important factor.
Yeah, that's a big part of it. I think like, it's, and in our case, it's not just about like moving the content out there, but actually moving out like some of the logic as well.
Okay. Yeah. Okay. And the last time we spoke, I think at Oktoberfest, funny enough, you mentioned that the edtech world is also like quite interesting, and it's an area I know quite well. I was kind of surprised that you actually want to serve such purposes as well. And like, are you actually doing something in the edtech world as well? Or is it like, what is your typical client?
Yeah, I mean, I would hesitate to talk about like the use cases of any specific client, but we're kind of all across the board. Like ad tech is one of the things. Media companies are another big one for us. And then e-commerce is like probably one of the biggest ones. They kind of see the value in. I think the primary reason e-commerce ends up being such a big part of what we do is because they really see the value in having low latency, right? You can actually measure the difference between 500 milliseconds and 250 milliseconds.
Yeah, and they typically have a business model that is also, I think, a plus.
Probably helps,
for paying for such a service. But Tyler, I think one of the reasons why you grew so fast is the fact that Google and others are actually pushing for web performance a lot. Is that true?
I think that is true. That's something that we spend a lot of time working on as well. A lot of the people who work at Fastly, like that's really what their background is working on web performance in the past. And then, Fastly came along and they got the opportunity then to figure out like, oh, how can I apply all these things that I learned at previous companies to everyone instead?
Okay. Growing so fast, just saying that you actually went public a year ago, I think?
That's true. May of last year.
Okay. And so it sounded first like a group of geeks that just does things for fun. That doesn't sound like that anymore. So how big is your team then?
So the company as a whole, I don't have the specific numbers off the top of my head, but we're north of 500 people at this point. My team is much smaller though. The office of the CTO is about 15 people.
Okay, interesting. One thing I find kind of interesting is the direction you're taking with Webassembly and being part of the Bytecode Foundation. Is it called like that? Bytecode Foundation?
Bytecode Alliance.
Bytecode Alliance. You actually started that off with a few other companies, Mozilla being one of those.
Yeah.
Can you tell a bit more about what it actually is?
Sure. I mean, I guess I should actually explain like how it got started as well. So, about 3 years ago, I personally started working on a project to find a good way to take untrusted code, make it fast, and be able to sandbox it. With the whole idea that I really wanted to be able to do what we refer to as like, some people refer to it as like nano processes, other people refer to it as like granular sandboxing. The whole idea is to have like very small, very fast, like ways of, running untrusted code in a shared way, right?
So like a Docker container, but just smaller, or?
Kind of, yeah. It's like a Docker container, but like much, much, much smaller, orders of magnitude smaller.
Okay.
And so when we got started working on this project, I went down a whole bunch of different paths trying to figure out a good way to do it. Eventually landed on WebAssembly. And then we discovered that some folks at Mozilla had been working on a new compiler for WebAssembly that we thought we might be able to adapt to be run on the server instead. So we started contributing to their code base and built some things around it. And then over time, that relationship started to deepen, and we were, now working with Intel and Red Hat as well on some projects. And so we decided that the right thing to do was to kind of turn it into an official thing.
Okay, it sounds really like amazing for a techie to work on such things and work with such companies, right?
It was pretty great, yeah.
Oh, okay. And like just to get a bit closer, so Mozilla is working with WebAssembly. Does it mean that there's like actually a runtime being embedded in every browser these days, or?
Yeah, so the one that we've worked on together is still in is in Firefox nightly right now. So it's not in the mainline Firefox yet. But yeah, so the whole idea here is that rather than just having the WebAssembly runtime and compiler embedded within the JavaScript runtime and compiler, it kind of deserves to have its own thing because it has its own unique properties and like opportunities for performance like optimization that JavaScript wouldn't necessarily have. Yeah.
And does that then mean that there's like it's like a new version of Flash or ActiveX built into the browsers, or like is it not as bad at that?
Oh man, so like I've definitely gotten this question quite a few times, and like I'm just happy you didn't go with Java applets. That would have been rough. No, so I can certainly see the similarities between the two. The main difference is that the trust model is entirely, well, I'm going to go with better for WebAssembly. WebAssembly actually is like, it's a very small, very like safe specification, like down to the point where it's like, it has tight proofs, it has small step and large step semantics now. And just the entire way that it's built is meant to be like sandboxed very tightly. And that's kind of the big difference. One of the other really big differences is that if you look at something like ActiveX or Flash, they had access to quite a bit of the infrastructure in the browser, like by default. WebAssembly, like by default, actually has access to nothing, right? So anything that it uses has to be provided by the outside system. And that's a very different place to start from.
So it's not able to access your hardware at all. It's not able to do anything with your computer.
Yeah.
Okay, but it's still bytecode. You as a user are not able to read and understand, or sure. I mean, is there some decompiler or anything? I mean, I really can't imagine. I mean, it's like a totally new world that is opening up there.
Shockingly, there actually is. I think it's in both Chrome and Firefox now. You can, if you load a WebAssembly module into the browser, it can actually decompile it for you and show you what it's doing.
Interesting. So Google also adopted it.
I believe so. Oh, WebAssembly? Yeah. Oh, yeah, absolutely. WebAssembly is actually in every major browser now.
Okay. Yeah. It's crazy.
And it's great.
Is it? Yeah, but does anyone use it? Right now?
Yeah, absolutely. So like, is it Google Maps, Google Earth? I can't remember exactly. A lot of like the applications that you're using are actually using WebAssembly, at least in like small components down underneath it quite a bit. Yeah, I would definitely say check out like the actual like the network thing and see what things are being loaded on major sites, because there's a bunch of stuff being used now.
And does it mean that it's like an applet embedded in a website? And
I would think of it much more like it's just a different language than JavaScript, right?
Okay.
It's an intermediate representation that can be targeted by a bunch of different languages, right?
Okay.
And to me, that's actually the most exciting part about WebAssembly. Like, I don't actually do a lot with WebAssembly in the browser. The thing that's exciting about WebAssembly is that it's like the first time we as an industry, we as like a group have kind of ever agreed upon a single intermediate language that can be used by like, a bunch of different languages, right? Like that's incredibly powerful if we can make it work well.
So it's a bit like LLVM or something, just in the browser, just very compact, maybe faster.
Yeah, that's kind of the idea. I mean, it's not faster than LLVM in most cases, but like the whole idea is that like LLVM was meant to make it possible to, to take a program that is compiled to LLVM bitcode or LLVM bytecode, and then translate that into, compile it into like for a bunch of different processors and platforms, right? WebAssembly goes a little bit further and says like, in addition to that, I'm also going to attempt to make it so that this thing can be sandboxed efficiently. So like WebAssembly makes a bunch of like fairly stringent requirements on the bytecode to be able to say like, this is exactly the amount of memory that it's expecting to have access to. These are exactly the functions it's going to access. These are exactly the functions it's going to export, as well as like the ability to say what's called, or the ability to have what's called structured control flow. So basically what it means is that there are no jumps. There's no go-tos inside of WebAssembly, right? So like everything is in the form of blocks, which means that it can be analyze to make sure that it's not doing anything that is unsafe with control flow. So a lot of the like lower level like attacks against programs these days use what's called ROP attacks. So return oriented programming. Basically, if you can find like little series of instructions and use them as widgets, you can jump around in a program and make different things happen. It's really weird and complex and like. But the whole idea with WebAssembly is that it should actually be impossible if you are compiling the WebAssembly correctly to do anything like that.
Okay. And which languages do you use then? I mean, compile to WebAssembly then?
Yeah, so the probably the best one at the moment is Rust, which I'm a big fan of personally. But C and C++ also work really well. There's a subset of TypeScript called assembly script that works well with it, and a bunch of other languages are actually coming down the line as well. Go has Go's implementation is getting more mature at this point, and as we add more features to the WebAssembly spec, we should be able to like put a whole bunch more languages on it as well.
Oh, it's really like a geeky thing, right? It's
yeah.
really, really deep, and I guess like barely no web developer knows about that, right? It's just being pushed out to the market and nobody knows it. Is it true, or am I just
yes and no?
Am I just a late adopter?
I don't think you're a late adopter. I think that not everyone needs to know about it. Mm-hmm. Of course, we want everybody to know about it, but like much in the same way that if Intel changes like the opcodes available on your processor, you probably don't care much about that, right? It doesn't come up in your like day-to-day like work life. WebAssembly is kind of one of those things that I think if it goes well, we'll actually end up just behind the scenes a lot of the time.
You basically adopted that to your CDN. So you basically built like an engine, a WebAssembly engine into your into your CDN, into Varnish, or
well, not into Varnish, but it is built into our platform. So it's an unusual one. So like all the browsers work by doing just-in-time compilation of WebAssembly. Our realization was that we could do ahead-of-time compilation of WebAssembly and make it even faster for our use case. So we have essentially like a compilation cluster that will turn WebAssembly into native code. But that native code, let's do the easiest way to explain this. The native code that it produces, like it's a compiled, object that normally comes out of a compiler, but along with that comes a contract of sorts. So you have this native code, as well as some information about like what the environment has to look like in order for you to be able to run this code safely, right? And so it'll say, this sandbox has to be at least this large, and it has to export only these functions and import only those functions, right? And so as long as the runtime, which is separate from the compiler, can fulfill all of the requirements of the contract, we can basically say that like it is safe for it to be able to run this program.
Okay, interesting.
Yeah.
And do you have any concrete examples or use cases for WebAssembly in your tooling in the real world? I mean, is it paid content, or what is like the typical use case for?
Sure. No, I think one of the best like pretty straightforward use cases that people have is GraphQL, right? Which GraphQL is obviously like growing quite a bit, but one of the things that people are often asking about is do they have the ability to serve GraphQL content and cache the individual components of it at the edge, right? So rather than saying like, I'm actually going to have I'm going to cache the final product. Instead, you could the user sends a request in. We actually fan that request out to a bunch of different backends, pull all that information in, cache all that information, and then pick out the individual pieces that were actually needed to resolve the GraphQL query.
So you have one content piece like articles or products, and you say you just want to cache that individual product data type inside a GraphQL API?
Right. So kind of like that. I guess what I'm thinking more is like you might say, I would like article number 1. Well, but we could actually just grab all the articles. So then we'll just go grab all the articles, cache all the articles, and then the next time someone comes along and says, I want article 2, we actually already have all of the articles there, right? And so it should make it a lot more efficient to resolve a lot of those GraphQL queries. That's the idea.
Interesting. I mean, if you're not in touch with CDN these days, you barely know that this can be done. I mean, interesting, but also really geeky.
Very geeky. Sorry, that's the way I'm gonna go.
And I also guess that coming to technology and leadership, this is how your team is structured. Or are there a lot of like deep geeks that like to play with their work, or like how does it look like?
Well, so that's interesting. My team is the office of the CTO. I only have about 15 people on my team, and it's a strange, diverse group of human beings. We refer to ourselves, like the way that we talk about what we do frequently is that we say that we watch the things that we look over We oversee the things that are overlooked.
Okay.
Right. And so that can mean a whole bunch of different things. Like we have people who are very good at like network protocols, like some of the authors of like Quick and HTTP3 and so on, like work on my team. And so, so we spend a lot of time looking at network metrics and so on that might be overlooked otherwise. So small things that are happening on the network that could be indicative of larger problems, for instance. But that's just like one half of the overseeing the things that are overlooked. The other half is kind of looking forward, right? Like where is the rest of the industry going, or where could we, drive the industry toward as well? And so this is, I think that the WebAssembly stuff that I'm talking about is one big aspect of that. Like that's something that we think is going to be really big in a couple of years. And so we're trying to get ahead of the game on that.
Okay. So I know, imagine like a big room with a black wall and a large TV screen at the end, where you see like a 3D globe visualizing all the world's traffic. Is that true?
Well,
and like a lot of people standing in front of it and asking, oh, is that a security thing, or is there what is happening in India?
Well, it's more virtual than that. My team is actually spread across the world. We have people all the way from Melbourne over to Paris as well, and including one here in Berlin as well.
Ah, interesting. So you are like a true remote first company, or?
Oh, yeah, I would say that's true. Some of our very first employees were remote. I think we are over 50% remote at this point. So it's something very much built into our culture.
Ah, cool. And how do you then like organize your meetings? Are you using like a certain tool chain, or like how do you manage to treat everyone the same? Is there like a thing you do to be really remote friendly?
We try to, yeah. So basically, every meeting at Fastly includes a video call link along with it. Typically, like if there are remote people, we try to all be remote for that thing. Doesn't always work, right? Because we do have offices in some locations, but yeah, like to me, it's really just about flexibility and like, making sure that people who are remote actually feel as if they're part of the team. And so we just make sure to talk a lot.
Okay. And you also sometimes work from home and stuff like that, or different locations to make sure that everyone's aligned and that it's working for everyone the same.
Well, you are talking to me in Berlin right now. So yes, we definitely get around.
Okay. So at Fastly, how do you do leadership? What kind of processes do you have? Do you have any processes in the office of the CTO, or like how does it work? Do you have OKRs? I mean, as a public company, there must be goals and so on implemented. How does it work?
Yeah. So the company as a whole obviously has like quite a bit of structure and process around it these days, and also a lot of like strategic planning. The office of the CTO is a little bit different. Like we do have strategy. But whereas like most groups, most departments think about strategy in terms of like a year or two, we look at our strategy more as like 3 to 5, 6 years long in the future, right? So the whole goal with that is for us to continue to, rather than focusing on what's happening right now, focus on what we think is going to be happening down the line. So everything that we work on tends to be longer term. And so that's how we do it. As for like specific processes, OKRs and whatever, I'm pretty bad at those sorts of things. I'm not really a process forward sort of guy. We kind of strategy via chaos. It's great.
But I mean, how do you then implement something like WebAssembly in your servers? Is there some way of, I don't know, doing experiments, or like how do you test if the thing will work for a client or not?
Yeah. So that is actually the thing that we spend a lot of time on in the office of the CTO is experiment, what I refer to as experiments and incubation, right? So I think one of the things that makes us different from what a typical like research group in a company might do is that rather than doing a bunch of research and then handing off our like findings to the rest of engineering, instead what we do is we actually incubate teams within the group. So the team working on WebAssembly, for instance, started with just me, and then I hired one other person, and the team started like growing from there. It's now like at least six or more people working on the project, just the core of the project together. And so that team has been spending the last like 2.5 years working together inside the office of the CTO. And so at some point here, we will actually move them out into the rest of engineering. So rather than incubating a project, we try to incubate teams instead.
Okay, interesting. But then you're really taking big bets at the end, right? I mean, you're like steering towards WebAssembly, and you know that the market will accept it, or you just bet on it.
Well, so I think that we spent a lot of time trying to like mitigate risk along the way.
Yeah.
Right. There were definitely some periods in there in which we thought, well, maybe this isn't going to work. That said, where we ended up going with it was basically like evaluating frequently along the way to go like, is this going to work? Well, what if we make these changes? Well, what if we partner with these people? Well, what if we instead of building on top of this platform, what if we build the platform ourselves?
Okay.
And so like the entire way along, we're like evaluating to make sure that we are not taking on too much risk, especially not taking on too much risk while growing the team, right? So before you grow the team, before you finish incubating the team, you got to make sure that it's actually going to work.
Okay, so I guess you work then closely together with a lot of like the most important clients, or like clients that like to experiment and talk to you, or how does it work then?
We talk quite a bit to our clients along the way to make sure that what we're building will actually work for them. Yeah.
Okay. Interesting. And do you then, you basically also like kind of a CPO then, right? Is that true, or is there any product person who overlooks all of the activities you do?
I would say that we kind of partner with products, whereas engineering, like I guess the way that I think about it is engineering is kind of downstream from product. Product kind of says like, here are the things that we would like to work on, the things that we would like to build over the next year. I look at the office of the CTO as kind of an input to products, right? So we have our experiments, we have our incubations, and then we go, here, product, take a look. Like this is what we have like discovered over the past couple of years. How can we build this into the roadmap?
Okay, interesting.
Yeah.
And what are your core technologies? I mean, we spoke about Varnish. It's, I guess, C-based, as far as I know, or is it like it sounds really low level?
Varnish is C-based. It is very low level. It is quite a beast of a project. We've done quite a lot to it to like make it work at our scale and work efficiently. But the way we're moving now is actually like away from C and toward Rust. Which I think has been a big shift, and like I've been very happy to see that even the people who were very long-term C programmers have really gotten behind it as well. And the big reason for that is that like Rust is kind of the first language that we've seen that actually combines like the efficiency, the performance, the low-level nature of C with the ability to make it safe, right? So like a strong type system and strong memory safety and so on. So like once you actually like wrap your head around Rust, it's a pretty amazing language. I will admit though that like the learning curve for it is a bit of a challenge.
Okay. And how many people at Fastly actually know Rust and know how to write Rust? Is it?
I'm not sure how many. I'm not sure I could count off the top of my head how many people, but it's quite a few at this point.
Okay.
Dozens.
Okay. I mean, it's really like gaining a lot of traction as far as I see. But I've just heard that it's like very, very hard to learn, and got like a rather like group of like really geeky people around it that drive it forward.
That is true. It definitely helps when you already have a bunch of people who can do it. They will definitely help to like train others up to make it work pretty well.
Okay. And one question we like briefly touched before, how does your server park look like? I mean, how many servers do you actually have? Is it more like mainframe computers that are based in, I don't know, like one place in Germany, for example, or are there like certain data centers? Are there thousands of computers? How does it look like?
Yeah, so there's a bunch of strategy that goes into how we do this part of our business. A lot of it is really based around there's several different things, right? So one of the factors is population centers, right? So we try to target areas that have large numbers of human beings who like to use the internet. But then it's not just about where there's population centers, it's also about like where our customers actually do business, right? And so, early on, that basically meant we were talking about like Western Europe and parts of the United States, right? And of course, over time, that has changed quite a bit. And now we're, much more global at this point. We're in Australia and New Zealand, all across Europe. We're in India, we're in Singapore, and down in South Africa and South America, and just all over the place at this point. As for what our points of presence, our data centers actually look like, again, like these kind of range anywhere from like 8 to 128 nodes, depending on just how much traffic there is in that area. It's actually pretty easy for us to upgrade those, add more servers, and so on. But the data centers themselves are actually like shockingly simple. And that's something we spent a lot of work on to make sure that like what we were building was going to be, straightforward to deploy and not complex to debug. So our data centers at this point are effectively just a handful of switches and a whole bunch of servers. And that's about it. That's really all that's in there.
And the servers are basically built at your company, or like, how does it work?
So the servers that we use, they're definitely custom built, but they are using all commodity hardware. It's nothing that is like too crazy, but they're powerful machines.
Okay, interesting. So you're not part of that Facebook Open Hardware Alliance or something like that, or is it?
Not just yet, no.
Not just yet. Okay. So it sounds like a quite impressive job, like having to handle all that hardware stuff and software stuff, and like really going down deep level everywhere.
Right. Well, I mean, I think what's interesting about it is that if you look at the way that a lot of companies that have large physical like footprints like we do work, there tends to be like a really strong separation between the hardware and the software teams. And that's something that we've really strived to avoid at our team, at Fastly. So one of the advantages of that is that the people who are working on like the infrastructural software for this actually understand like what our data centers look like and how the data centers work, which ends up meaning that they can build software that actually takes advantage of that. So I think we've talked publicly about some of the software that we've written that runs on the switches themselves, right? So rather than having load balancers and routers and all sorts of other physical devices in our data centers, we do almost all of that in software, either on the server or on the switch.
Okay, and on the servers, do you have something like Kubernetes or anything to like arrange it all, or is that just too much overhead?
So it's a really interesting question, because like we've talked about doing this sort of thing in the past, but what we've always landed on is that it's not actually necessary for our use case, because ultimately what we want is for every server to be identical. So it doesn't really matter, so we don't really need a thing that decides what's going to run on the servers, because the answer is the same thing as everywhere else.
Okay. And so a server boots up and just downloads an image from somewhere and that just runs it, or
something like that. Yeah.
Okay. Interesting. Tyler, one small surprise I have here. So we thought till now that this device on the table is an audio recording device. It's not. It's a time machine I got from Sergey Brin, and we now travel back in time to your first day at Fastly, and you have a chance to whisper something into young Tyler's ears. What is it?
Oh man, there's so much I would want to whisper into my own ear. So many mistakes made. I think probably the first thing I would whisper to myself would be, don't be afraid of process. I came into my role with the perspective of someone who had been an engineer for 10, 12 years at that point. And so I was still afraid of things like you were mentioning, OKRs and managers and all those sorts of things that are always scary when you're a young person. Now I've kind of come to realize just how important those sorts of things are in actually developing a growing company, right? And I that's definitely one of those things where I wish I had adapted to that a little bit earlier. It would have made life easier for me, at least.
Okay, yeah, I understand that fear and the wish to just sit in front of a computer with boxer shorts on and just code.
Yeah, never goes away, does it?
Yeah, it never does. Yeah. Okay, so do you then sometimes still code? I guess so. Yes, right?
I do occasionally. It really depends on what projects are actually going on at that point. It's been a little bit of time since I was actually writing much code, but I am hoping to get back to it pretty soon.
Okay, very good. So you implement your next incubation project and then you can code again, right?
That's the goal.
Okay, very good. So Tyler, thanks a lot for the interview and thanks for actually being here in Berlin. It's an honor to talk to you and looking forward to the next occasion then.
Hey, I'm really looking forward to it as well. Thanks for having me.
Thanks. Bye.
Bye.
Thanks again to our sponsored MongoDB. To try the new cloud product of MongoDB called MongoDB Atlas, just go to cloud.mongodb.com and use the promo code podcast2020 to get started for free.